Everyone loves roller coasters. They are fast, exciting, and reach great heights. But have you ever thought about what goes into actually building a roller coaster? One of the world's most famous roller coasters, the Top Thrill Dragster, is known for reaching speeds of 120 miles an hour and a height of 420 feet.
You have to start a project like this from the ground up, so you bring in the mechanical engineers. They design the coaster itself and incorporate into it all the little machines that make the roller coaster work. Then, grab some electrical engineers and set them to work on making sure that not just a roller coaster, but all of its bells and whistles have enough electricity to operate. Now, in order to keep this house of cards from falling down, you're going to need some structural engineers. They work to ensure that the ride doesn't fall over and give all those people a legitimate reason to scream. Lastly, now that the ride works and won't fall over in the breeze, you can bring in the industrial engineers. They determine just how many people can ride the roller coaster at a time while making sure it also operates safely.
Needless to say, there are a multitude of different ways that a roller coaster can be propelled at high speed with all of these great minds at work. However, the technique that has been used to the greatest effect with regards to making the biggest and fastest roller coasters has been shown to be the ubiquitous hydraulic system. Implemented in coasters such as Cedar Point's famously intense thrill machine, the dragster, a hydraulic system functions by taking advantage of Pascal's law, which states that for a fluid at rest, the pressure is equal to the force applied divided by the area it acts on. In a closed system, the amount of pressure created by the force applied will be converted directly to a force being applied on the other piston, as seen in the provided image. If, in this situation, the area of the second piston were 20 times larger than the piston that you were pushing down on, then, according to Pascal's law, the force exerted on the second piston would be 20 times larger than the force put on the first piston. Basically, hydraulics causes a comparatively small amount of horsepower to be converted into a much larger amount of force.
Now that you know all about the Top Thrill Dragster and how some modern roller coasters work, you're probably wondering what's next for these thrill-seeking machines. Roller coasters' main components, such as loops, big drops, and twists, will likely stay the same over the next couple of years. This is because a lot of these ideas were thought of in the early 20th century, and thankfully, physics doesn't change. Roller coasters will always get taller and faster, but their main components should stay the same. One big change for roller coasters, though, is virtual reality. Some amusement parks, such as Six Flags, have added virtual reality sets to their roller coasters. This can put riders in a different world, while still enjoying the thrills of a roller coaster. Six Flags has also added a device called a black box, which helps give each rider the best experience by lining up their virtual reality with the location on the track. This new feature for roller coasters gives a fun new way to enjoy them.